Welcome to the Deep Dive. This is where we explore fascinating topics using the sources you share with us. And today, well, prepare to get immersed.
We really are going deep today.
We are. We're heading into this hidden world where water meets soluble rock. It's this slow, kind of beautiful dance that creates subaqueous caves and these incredible terrains called karst landscapes.
It's amazing, isn't it? Beauty forged in darkness, really, both underground and, shaping the surface too.
Exactly. And you, our listener, showed a real interest in this watery artistry. So we pulled together insights from geological surveys, firsthand accounts from cave divers.
Intrepid is the word.
Right. And explorations of some truly awe-inspiring cave systems. We want to bring you a vivid picture.
So we'll be looking at how caves form, drawing on the USGS info, and then what cave diving actually involves, using insights from the NSS cave diving section.
Yeah, and we'll also touch on those unique underwater features in Mexican cenotes and glimpse some of the most spectacular karst areas around the world. Okay, let's unpack this liquid labyrinth.
What's really captivating, I think, is how this simple interaction, just water and rock, plays out over such immense timescales. It creates these incredibly intricate and diverse environments.
More than just geology, then.
Oh, absolutely. You've got hydrology, biology, even human history all intertwined in there. It's a real mix.
Okay, so to get our bearings in this sort of subterranean world, what exactly is a cave? And what does karst really mean?
Well, basically, a cave is just a natural opening in the ground. It has to go beyond where sunlight reaches and be big enough for a person to get into.
Okay.
And they can form in all sorts of rock types through different processes. The scale varies massively, too, from little rooms to huge networks stretching for hundreds of miles.
Right.
And the science of studying them, the speleology, it pulls from geology, hydrology, biology, archaeology. It's really interdisciplinary.
The speleology sounds like unlocking Earth's secrets. And karst, we hear that term a lot geographically.
Yeah. Karst is the bigger picture. It describes landscapes mainly shaped by dissolving soluble rocks, think limestone, dolomite, gypsum mostly.
Ah.
And what's really striking is that something like 12% of the Earth's land surface is actually karst.
12%, wow.
Yeah. So these water-sculpted landscapes are, well, they're much more common than people might think. They massively influence water cycles, often host unique ecosystems. Something to remember when we think about conservation.
Definitely.
Caves are a key part of karst, obviously, but the term also covers surface stuff like sinkholes, disappearing streams, springs, all that.
12%, that really puts it in perspective. So let's go deeper. How do these incredible caves actually form?
Well, the main way, especially for those big systems in karst areas, is through dissolution.
Dissolution.
Dissolving, basically.
Exactly.
Yeah.
It happens mainly in those carbonate and sulfate rocks, limestone, dolomite, marble, gypsum. The key player is slow-moving groundwater. It's usually a bit acidic because it's picked up carbon dioxide from the air and soil.
So this slightly acidic water seeps into cracks, fractures, bedding planes in the rock. And over, vast amounts of time, this constant flow just gradually dissolves the rock, widening these paths into tunnels, passages, sometimes huge caverns.
So it's like water acting as a very, very patient sculptor.
Precisely. Like slow motion erosion, but happening underground. And while these solution caves are the most common, and usually the biggest, there are other types too.
Oh.
Yeah, you get lava caves, basically tubes left behind after lava flows and cools. Aeolian caves, carved by wind-blown sand in deserts. Glacier caves, formed by meltwater and ice. And wave-cut caves, eroded by ocean waves on coastlines.
That's quite a variety. I just thought water.
And look, for most big cave systems, especially in karst, you're right, water is the main story. But what's interesting is how our understanding of how it happens has changed.
How so?
The older idea was that caves formed above the water table, with water dripping down. But now the consensus is that the main initial dissolving actually happens just below the water table.
Below, in the saturated zone.
Exactly. Right in that zone where the rock is fully saturated and the groundwater is constantly moving, albeit slowly. That's where the initial dissolving work gets done.
So the groundwater level is key right at the start.
It seems to be. The basic layout of the cave passages often forms horizontally near that water table level. Then maybe the water table drops over geological time, perhaps a nearby river cuts deeper.
Okay.
And suddenly those water-filled voids are left high and dry in the unsaturated zone. Air gets in. And that's the second stage, the one that allows all those amazing decorations to form.
Ah, right. Stalactites and stalagmites. Let's talk about those. What are these things? Speleothems, is that the word? How do they actually grow?
Yes, speleothems, that's the collective term for all those decorative dripstone features. And their formation is basically the reverse of the dissolving process.
The reverse, okay.
So in that air-filled cave, you have water seeping through the limestone above. It's picked up dissolved calcite and carbon dioxide on its way down. When that water hits the cave air, the carbon dioxide escapes, kind of like fizz leaving a soda bottle.
Hey.
Losing that CO2 makes the water less acidic. The dissolved calcium bicarbonate becomes unstable and precipitates out as solid calcite. Drop by drop, layer by layer, this calcite builds up.
So the cave is kind of breathing out minerals.
That's a great way to put it. It exhales mineral art. And the most famous are stalactites hanging down from the ceiling. Each drip leaves a tiny ring of calcite.
Sometimes they form those really thin, hollow ones.
Yeah, soda straws, they can get surprisingly long, like a yard or more sometimes, incredibly fragile.
Yeah.
If water flows down the outside of a soda straw, it thickens up into that classic cone shape we usually picture.
And stalagmites are the ones going up from the floor.
Correct. Formed by the water dripping down from above, often from a stalactite tip. And if a stalactite and stalagmite grow long enough to meet...
They form a column.
Exactly. Floor to ceiling. Then you have curtains or draperies, these thin, wavy sheets hanging from sloped ceilings where water trickles down a surface.
Oh, like frozen fabric.
Sort of, yeah. And flowstone is similar, but it's like sheets of calcite coating walls or floors where water flows more broadly. Think frozen waterfalls. Jewel Cave in South Dakota has some amazing flowstone draperies.
Those features are so visual.
Yeah.
What about those little fence-like things you sometimes see around pools?
Ah, rimstone dams or gores. They form right at the edge of pools on the cave floor. Calcite precipitates out there, building up these little barriers, often in terraces, holding back pools of water.
Okay.
Then you get the weirder stuff. Helictites, these bizarre, twisted, spiraling things that seem to ignore gravity.
How do they even form?
That's still debated. Maybe
Yeah.
capillary action, maybe wind currents in the cave. They're strange. And cave corals, these little knobby clusters formed by really slow seepage. Very intricate.
It's just mind-boggling the time involved, millennia of slow drips building these underground sculptures.
It really is humbling. And besides these decorations, caves hold other clues. Cave fill sand, clay, gravel washed in can contain records of past climates and geology.
Like a time capsule.
Pretty much. And break down just fallen rocks from the ceiling or walls tells you about the cave's own structural evolution.
Okay, so we've got the basic cave carving and then the decorations. Let's move into that zone where air meets water, the subaqueous caves.
Right. Many cave systems don't just stop at the water table. They keep going down, fully submerged. This leads to the very specialized field of cave diving.
Underwater caves.
And a fantastic place to see this is the Yucatan Peninsula in Mexico, with all its cenotes.
Ah, cenotes. Those amazing sinkholes. How do they link up with these underwater cave systems?
They're basically windows, natural sinkholes formed when the limestone bedrock dissolves and collapses. They give direct access to the groundwater and these huge underwater cave networks. They're like portals to that submerged world.
What's it like down there? What unique things do divers find?
Well, one really striking thing is the halocline.
Halocline.
Yeah, it's a boundary layer where fresh water from rain sits on top of denser salt water that's seeped in from the sea because they have different densities and bend light differently.
It looks weird.
Very weird. It can look shimmering, blurry, oily, like swimming through distorted glass or oil and vinegar. It's quite surreal. And the depth of this halocline can change, telling us about past sea levels and groundwater flow.
Wow. What else is down there?
You find submerged versions of the formations we talked about. Flowstones, stalactites, draperies, rim pools, all underwater now. Exploring them needs, well, very specific training and gear. It can be zero visibility, complex passages.
Clay stakes?
Definitely. You also find living formations, biofilms, bacterial mats thriving without sunlight. They can be colorful, and they're part of the cave's ecosystem, sometimes even helping minerals deposit. And yes, you can find rimstone dams underwater too, still influencing water flow.
It's like a whole hidden dimension opens up below the water. I read about something called Hell's Bells in one cenote.
Sounds ominous.
Yes, El Zapote cenote. The Hell's Bells are incredible. They're very different from normal speleothems formed in air.
How? There are these large, bell-shaped underwater formations. The thinking is they form through complex interactions between water chemistry and microbial life, right at a specific zone called the redox line.
Redox line.
It's a boundary layer underwater where chemical conditions change rapidly. Things like reduced sulfur, carbon, nitrogen diffuse upwards from deeper water, and this drives a unique kind of calcite precipitation, likely involving microbes. It's not the simple dripping water process like stalactites. It's a whole different chemical and biological soup creating them.
Fascinating. So different conditions, even in the same cave system, create totally different things. Now, cave diving itself sounds incredibly challenging. What's the key focus?
Safety, absolutely paramount. The NSS cave diving section really hammers this home. The most important piece of gear is the diver's mind. Proper training, the right attitude, discipline, that's everything.
Makes sense.
And the core principle, a successful dive is one you come back from, period.
That says a lot about the risks.
It does, but interestingly, statistics show that for a trained cave diver, the drive to the dive site is statistically riskier than the dive itself.
Really?
Yeah. The real danger is for untrained divers, usually open water certified divers who go into caves without the specific skills, gear, and mindset. They don't understand the overhead environment, the lack of direct descent, the potential for silt outs. That's where most tragedies happen, sadly.
So it's about specific training for that specific environment. What about closing dangerous caves? Is that done?
Generally, the community prefers education and clear warning signs over outright closures. Organizations work hard to educate divers and post signs warning untrained divers not to enter. It's about empowering people to make safe choices.
Education over restriction. Okay,
Yeah.
so why do people do it? Is it just the thrill?
Well, the exploration and the beauty are huge draws, for sure. But cave diving also contributes a lot scientifically. Divers often work with geologists, hydrologists, biologists. They provide access to places no one else can reach. They collect data on water flow, water chemistry, unique life forms some microbes found have potential medical uses, for instance. They can help monitor water quality and protect groundwater resources.
So there's a real scientific value, too. What does it take to become a cave diver?
It's a serious commitment. You need advanced open water certs, lots of logged dives in varied conditions, excellent buoyancy control, problem-solving skills.
And mental fortitude, I imagine.
Absolutely. Calm under pressure, self-awareness, respect for limits. Plus, the gear is specialized, expensive, and redundancy is key. Back up everything: lights, breathing gas, navigation. Renting gear for training is usually the way to start.
Redundancy. Yeah, that makes sense when there's no easy way out. Okay, we've spent a lot of time underground, but karst landscapes, they shape the surface too, right? In big ways.
Oh, definitely. Caves are just one part of it. The surface can be just as dramatic. Think about Mammoth Cave in Kentucky, the longest cave system known, over 580 kilometers of passages. That exists within a huge karst region full of sinkholes and disappearing streams.
580 kilometers. Unbelievable.
Or Sun Dune Cave in Vietnam, the biggest single cave chamber known. It's just colossal inside a karst mountain range.
What about surface features we can actually see more easily?
Sinkholes are probably the classic example. You have massive ones like Shazai-Tianking in China, or underwater ones like the Great Blue Hole in Belize's famous dive spot.
Right.
And some sinkholes, like the ones on Serra Plateau in Venezuela, are still kind of mysterious in how exactly they formed. Adds a bit of intrigue.
Geological mystery is cool.
Then you have karst pavements like the Burren in Ireland,
Yeah.
huge areas of exposed limestone, all cracked and dissolved into these amazing patterns. There are places like the Globe at Knockin in Scotland set up specifically to teach people about karst.
Local examples too.
Sure, Scenic Caves in Collingwood, Ontario is a good one. Jada Grotto in Lebanon is stunningly beautiful within a karst area. And then you get those really iconic landscapes, the karst towers in Yangshuo, China.
Oh yeah, those pictures are amazing.
Exactly. Or the stone forest in Yunnan, China. Looks like a forest made of limestone pillars. It's all shaped by that same dissolving process.
It's incredible how widespread and varied it is. Globally significant. Okay, finally, let's talk about people in caves. It's not just geology. There's a long human history there too, isn't there?
Absolutely. Caves were some of the first natural shelters. We find evidence of early human ancestors using them. Australopithecines, Neanderthals, and then, of course, the cave paintings.
Lascaux, Altamira.
Right. Cro-Magnon art, over 10,000 years old. Amazing windows into their world, their beliefs, maybe. Caves were clearly important places, not just shelters.
Sanctuary and canvas. What about later history? More practical uses?
Definitely practical. Nitrates for gunpowder were mined from caves, especially in the U.S. during the War of 1812 and the Civil War. Mammoth Cave was a big source.
Gunpowder from caves.
Yeah, from the breakdown of bat guano and other organic materials reacting with the rock. And bat guano itself was, and sometimes still is, mined as a really rich fertilizer.
Resource extraction. And today, how do we interact with caves now?
Well, recreation is huge: sightseeing, spelunking, caving. But some are used as natural tunnels. People look at them for cold storage, potentially water supplies. Some have even been designated as fallout shelters.
Huh.
And scientifically, they're vital natural laboratories for understanding groundwater aquifers, unique biology. But building in karst areas can be tricky. Ground stability is a real concern.
Right. Sinkholes don't mix well with buildings.
Exactly. And conservation is crucial. Caves are fragile. Vandalism, pollution, disturbing bats, it's easy to cause damage. Ethical caving is key. The whole take nothing but pictures, leave nothing but footprints idea.
It really hammers home that these aren't just rocks and holes in the ground. They're complex systems, geological, ecological, historical.
Totally interconnected. We've journeyed from, the dripping dark into these vast decorated caverns, looked at the science, the diving, the global scale. These hidden worlds hold so much significance.
Just think about the sheer power of water, drop by drop, drip by drip, over millennia, carving out these incredible spaces, both underground and shaping the land above. It makes you wonder, what other hidden marvels are down there waiting to be found?
Good question.
If this dive into the subaqueous world, into karst, has sparked something in you, maybe like sunlight hitting that clear cenote water, well, let that light guide you over to the All Sorts podcast on YouTube.
Yeah, come join us there.
Like that slow, steady drip building a stalactite, every share helps us build this community. So please subscribe so you don't miss our next deep dive. And just like those underground rivers connecting vast cave systems, our back catalog of All Sorts podcast explorations is there for you. Follow the flow, check out our other episodes, and keep the conversation going on X, Instagram, and Threads. Let's keep that current of curiosity flowing strong.